Now let's find the following sum and prove it. Okay, we are interested in finding the sum of the cosine kx, where k is going from 0 to n. Okay, we can prove that this sum is sine of n plus 1 over 2 x cosine of n over 2x. Everything is over sine of x over 2. Here we don't want to add the sign to be 0. Okay, that's why we have to restrict it to have the domain. So x is going to be different from 0 modulo 2 pi. Okay, so this is here because we don't want a sine of x over 2 to be 0. Okay, so to prove this result here, we're gonna do the following. We're gonna use some trick. I proved a similar result concerning the sum of the sine, the same result, but with a slight modification. Here we have the sine of n over 2 times x. I proved it using the induction. Okay, you can do the same thing here, but we need to do a slight change of the formula here when doing the addition. Okay, very simple, similar to the proof of the sum of the sines. But here we're going to use a different technique. Okay, so if we multiply by sine x over 2, this formula here, we should get this one here. Okay, that's what we're going to do. But to do that, we need to remember that the sine of a plus b is the sine of a cosine b plus the cosine a sine b. And the sine of a minus b is the sine a cosine b minus cosine a sine b. So if I multiply the cosine by the sine, I should get these formulas here. That's why I add these two, because that's what I need. So I have 2 sine a cosine b is sine of a plus b plus sine of a minus b. Okay, and remember which one is the a, which one is the b. It's very important when dealing with these ones. Okay, so we gotta use this one here. Okay, so we have this sum, the cosine. K going from 0 to n is 1 plus cosine x plus cosine 2x plus cosine nx. Okay, here if we multiply by sine x over 2, we do the same thing here, sine x over 2. Okay, here to use our formula, this one here. Okay, so we need to divide by 2 because we don't have these two here in these sums here. Okay, so we have 1/2. Okay, so the cosine of 0 is 1. So I have sine of x over 2 times cosine of 0 plus sine of x over 2 times cosine x plus sine of x over 2 times cosine 2x, and plus the last one, sine, etc. The dots, it means that I did the same multiplication for all the others. Okay, here I have 1/2. Now I'm gonna apply my formula here. So in this case, a is x over 2 and b is 0. So I have sine of x over 2 plus sine of x over 2. And here I have a is x over 2 and b is x. Therefore, I have sine of 3 over 2x plus sine of minus x over 2. And here I have sine of 5 over 2x plus sine minus 3 over 2x. And I'm going to keep going until the last term. So I'm going to have the sine of n plus 1/2 x plus sine of n minus 1/2 x. Okay, so here I have 1/2, and now given that the sign is odd, this one will give me a minus, so let me write it here. Given that the sign is odd, I have sine of x over 2 plus sine of x over 2 plus sine of 3 over 2x minus sine of x over 2. It's coming from here. Plus sine of 5 over 2x minus sine of 3 over 2x. And I'm going to keep going until the last term. I have sine of n plus 1/2 times x minus sine of n. Here I should have the last, I should have 1/2 here. I should have 1/2 minus n. Okay, here notice that a is 1/2 and b is n. As here I should have 1/2 minus n. That's why when I get here I have minus n, minus sine n minus 1/2 x. Okay, so this is good. Okay, now I can see that I can do some simplification. Okay, this one will go with this one, this one will go with this one, and this one will go with some term. All I have is this one will go to previous term here. All I have left is 1/2. Okay, sine x over 2 plus n plus sine of n plus 1/2 x. Okay, now I'm going to use another identity. Is that the sine of p plus the sine of q is 2 sine of p plus q over 2 times cosine of p minus q over 2. This is a side note. To prove this result, you can expand these two and get back to this. Now I'm going to use it here. To use it here, I'm going to assume that p is x over 2 and q is n plus 1/2 x. Therefore, these two will go with these two here. So what I have now is the sine of p plus q over 2. That means x over 2 plus n plus 1/2 x, everything over 2, times the cosine of x over 2 minus n minus 1 over 2 times x over 2. Okay, now I'm going to do some simplifications. I have the sine. Here, the 1/2, the x over 2 will go with the x over 2 to give me 1. So I have n plus 1 over 2 times x times the cosine. This x over 2 will go with 1/2. Okay, I should not put this one. I should put this one here. Okay. So if I do it here, it's like a multiplying everything here. So I have and I should, if I put this one here, I should put plus here. Okay, therefore I have here n over 2x. Okay, now I multiplied the sum. Okay, the sum, I multiplied the sum by sine x over 2 to get this result. So to get only the cosine, I need to divide back by the sine of x over 2. Okay, and this gives me my result that I'm wishing for, which is the sum of the cosine of kx. Okay, this is very useful. So x can be pi over something, it's very useful when we're gonna see that we're gonna need it. Okay, this proves that we get the result that we need. Okay, it's some bit of algebra and some tricks, that's it, and paying attention to the sign and the minuses that they can trick sometimes. And I think that's it. If you see any errors or mistakes, please let me know, and thank you again Please like, share, and subscribe. Thank you.